Hello everyone! Today we are going to continue looking at identifying quadrilaterals. And last time that we did that, we focused on parallelograms. This time we're going to focus on rectangles, rhombi, and squares. And remember that we've already talked a lot about the rules of diagonals in rectangles and in rhombi. And it turns out that all of those rules that we found can actually be used in reverse. So, for instance, if you know the diagonals of a parallelogram are perpendicular, you'll be able to say it's a rhombi. Or if you know that the diagonals of a parallelogram bisect the two opposite angles, you can say it is a rhombi. We can do the same thing with rectangles. If the overall diagonals are congruent in a parallelogram, it has to be a rectangle. And maybe we'll be able to make some more conclusions later, but let's start with those and let's actually add just two more, or just a few more. First off, it turns out that you actually only need one diagonal of a parallelogram to bisect a pair of opposite angles in order for that parallelogram to be a rhombus. And we are going to skip the proof for that for now. We might return to it later should we have time. The other thing to look at is if you know that two consecutive sides of a parallelogram are congruent, it will then be a rhombus. And that's because if you're looking at a parallelogram like this, and you know it's a parallelogram, due to the properties of parallel lines, if this side is congruent to this side, you'll already know it's a rhombus because those parallel lines are going to ensure that the opposite sides are also equal, right? Because we know that from a parallelogram. So all you really need in order to say, oh, this is a rhombus, is that it's a parallelogram with these two markings. And you'd already be able to say rhombus. But make sure that you only do that if you know it's a parallelogram. Because if you don't know that this is a parallelogram, this could in fact be a kite. So just watch out for that. The next thing that we can conclude, and this is the other new one, and that is if the full diagonals of a parallelogram are congruent and the diagonals are perpendicular, the figure is a square. So in other words, if something is both a rectangle and a rhombus, it has to be a square. And that makes sense because if you look at a square, well, it has all equal sides, that's the rhombus part of it, and it has 90-degree angles, that's the rectangle part of it. It is a parallelogram, so all of the qualities of both a rhombus and a rectangle are present in a square. Therefore, if you see, oh man, I don't know, it seems like it's both a parallelogram and a rectangle, oh, and it's a rhombus, well then go, of course, that means it's a square. So we can use that to classify a bunch of different shapes, and let's just jump into those. So for this first one, I'm going to assume, according to the directions, that all are parallelograms, which remember is essential information. So if I'm looking at this first one, I can see that the diagonals are perpendicular. Well, if the diagonals of a parallelogram are perpendicular, I can say it's a rhombus. So I'll write rhombus. Now I can't write square because I don't know that the diagonals are equal. And even though from the picture it looks like they are not, remember that you cannot trust a picture. It could very well be a square for all we know, because all we really know is that it's a parallelogram with perpendicular diagonals. For our next one, well, we have that each of these diagonals are equal in length. We also have that this is a right angle. Didn't come through very clearly, so I'm just going to darken it there. You can also see that these diagonals are perpendicular bisector, or are bisected by the diagonals. So that means that because they're bisected by the diagonals, this must be a rhombus, right? It has to be a rhombus because even if one of those diagonals bisects a pair of opposite angles, it's a rhombus, and we have both. We also know that because those are at 90-degree angles or perpendicular, it has to be a rhombus. So for sure this is a rhombus. But the thing is, see how these two are equal lengths to each other? That means that this whole diagonal AB would be congruent to this whole diagonal CD, because if this is x, then this is x as well, so that'd be like 2x. And if this then would have to be x, and this would have to be x, the length of this one is 2x as well. So because our diagonals are congruent, that means that this is also a rectangle. Therefore, since it's both a rhombus and a rectangle, This has to be a square. Next, notice how we have these markings. And I'm going to add this in just to be extra clear. What this is saying is that the lines here, our diagonals, are bisecting our angles. Now, I don't know anything else about them. I don't know anything about length, but that information alone is enough to say that this is a rhombus. In our next one, we are told that, well, all equal sides. So already I could say that this is a rhombus. But even if that hadn't been drawn in as all equal sides, I could say that this is a rhombus. I know it's a parallelogram from my givens. It was said in the instructions itself. And I know that one diagonal bisects opposite angles. So that means it has to be a rhombus. Last but not least, I'm given this parallelogram and I'm told that AC is congruent to DB. That means that since the diagonals are congruent, this has to be a rectangle. And I would be done. Now, I have a few practice problems for you guys to do. Those are listed on Classroom. And on Monday, we are going to be taking a quiz on that, on all of this. Now, remember that you have to be comfortable identifying rectangles, rhombuses, squares, and just general parallelograms from a picture. And it's possible that I might not give you enough information to say it's any of those, and you might just need to say it's a quadrilateral. So be careful with that. Make sure to check in with me if you have any questions. And while I won't be on Zoom today, I will be available via email or comments, so don't be afraid to send me questions there. I hope you guys have a wonderful weekend, and we're almost there to that Christmas break, so keep pushing through. Great work. Have a great day.